Hello everyone, and welcome back to the Fluctus channel. In 2007, European aerospace giant Airbus unveiled the largest passenger airline in history, the double-decker A380. The company launched the $10.7 billion program back in 2000 with the hopes of taking over the long-haul flight market from the Boeing 747. The final A380 boasted seating for between 525 and 853 passengers and had a range of around 8,000 nautical miles. As with most Airbus aircraft, the A380 is produced in sections spread all over the European continent. These sections are then assembled at the company's Toulouse factory in France. A sprawling facility that covers more than 1,700 acres and employs more than 20,000 people. The process of creating an Airbus 380 is truly impressive. After all, these planes are 238 feet long and boast a wingspan of around 261 feet. As such, the various components that make up the aircraft are incredibly large, often weighing tens of thousands of pounds. These pre-assembled components arrive on flatbed trucks, many of which require police escorts due to the sheer mass of the sections. Here, you can see the wings being painted while sections of the fuselage continue to arrive. For particularly large sections, Airbus will often employ its Beluga XL transport aircraft, which has an extended fuselage so that it can more easily carry oversized components. Assembly utilizes special flatbed vehicles and massive, ceiling-mounted cranes to move the various sections of the aircraft into place. These are then pieced together using a combination of manual efforts, robotics, and heavy machinery. At this point, only the wings and tail sections are painted. The main fuselage is still covered in an anti-corrosive coating. The nearly completed aircraft is then moved to a separate assembly hangar where the four massive Trent 970 turbofan engines are installed. From here, the fully assembled aircraft is moved again so it can undergo its very first flight test. After its flight test, the new A380 is ready to undergo the painting process. Before delivery, the rest of the plane will need to be painted to match. The first coat is white, After which, special plastic covers and tapes are utilized to protect that new coat from the secondary coats. This is for the lettering and other detailed sections, and it needs to be applied by hand. Due to the sheer size of the plane, it takes multiple teams working in tandem to accomplish this task. In many cases, they need to utilize special motorized lifts to reach all the different sections of the aircraft. The paint used is very toxic in its liquid form, so it's crucial that the painters wear specialized suits and masks to prevent them from inhaling paint particles. Once the paint is dry, the protective plastic covers are removed, revealing the finished product. Not only is the Airbus 380 one of the most advanced passenger aircraft in the world, but they boast features not found in many other designs. Each airline had different specifications for the interiors of their aircraft. In most cases, the furnishing and decorations are requested to fit a specific theme or aesthetic. This process is also handled by the Airbus team, who must install a wide range of cabin equipment, storage containers, and seating according to the client's specifications. In Qatar Airlines, the seats are designed with the same royal purple features in their logo and exterior paint. This particular aircraft also includes various sectional seating for premium passengers in first class or business class. Even with Airbus's resounding success, few aerospace companies could possibly compete with the industry titan that is Boeing. Since the 1950s, Boeing has produced top-tier commercial and military aircraft, including the famous 747 airliners and the C-17 Globemaster. More recently, the company unveiled its 787-9 Dreamliner, a wide-bodied aircraft capable of transporting nearly 300 passengers over 8,700 miles at a time. The aircraft even set a record for the longest commercial flight in March 2020, traveling from French Polynesia all the way to Paris without refueling. One of the things that set Boeing aircraft apart from the competition is the company's rigorous testing processes. This includes engine out testing, in which aircraft are forced to take off with significantly reduced engine thrust. This is done to see how the plane might behave if it were to lose one engine during flight. Here, you can see a 787 undergoing what's known as fatigue testing. This is intended to discover potential damage or weaknesses in the wing or fuselage. The Dreamliner is first mounted on a specialized test rig. After that, a series of technical devices are attached to the exterior. This allows engineers to push and pull at various parts of the aircraft frame, mimicking the ground-air-ground cycle, from taxi conditions to takeoff, landing, and more. What's even more impressive is the length of these tests. In many cases, the frames will see non-stop simulations for 3 years. Another extremely important test that all Boeing aircraft need to pass is the so-called water intake test. This is designed to ensure that aircraft passing through standing water on the runway will not spray water up into the engines. Though these engines are designed to remain operational if the water is ingested, too much water could potentially cause a failure. This is done by building a pool in the center of a runway and painting specific sections of the aircraft with a pink dye. When sprayed with water, the dye will immediately start to dissipate, allowing the testing team to see precisely where the water struck the aircraft and how much of it reached the engines. In the case of the 747-8, the plane was able to move through the standing water at different speeds while remaining flightworthy. Back on the engine testing runway, the Dreamliner is being prepared for such an eventuality. To simulate an engine failure during takeoff or landing, the test pilots direct the plane down the runway and then unexpectedly turn off one of the engines. This causes the aircraft to list to one side. The goal is to ensure the aircraft can safely recover from such a failure. However, Boeing also wants to provide pilots with detailed information on how to react should such this occur in real life. When it comes to military aircraft, tests need to be even more rigorous. This is the Boeing Saab T-7 Red Hawk, a small-scale advanced jet used by the United States Air Force for testing and training pilots. In this particular exercise, the test pilots are going to shut down and restart the plane's only engine while in midair. This is essential to providing that the aircraft can perform as anticipated. This eventuality has been done multiple times in the T-7 simulator, but now it is time for the real thing. At 20,000 feet, the test crew shut off the engine for a full 45 seconds. The engine is then restarted. this particular case, the T-7 passed with flying colors. Yet another Boeing division focuses on producing aircraft for NASA. A good example of this is the Boeing X-37 orbital test vehicle, a reusable robotic spacecraft that had its first flight in 2006. Like the space shuttle before it, the X-37B is intended to return from space and land just like an airplane. As is to be expected, the experimental craft underwent rigorous testing to see if it would perform as the engineers expected. Since then, all three versions of the X-37 have completed multiple successful space flights, again proving the importance of the testing process. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.